Hello, geometry friends. Today we are going to work on a lesson about the altitude drawn to the hypotenuse of a right triangle, which is kind of a niche idea, but it's interesting and it develops a couple cool themes. So that's what we're going to look at today. So if you find day 3 notes here, what we're going to look at here is first, what the heck is a right triangle and why do we care if we have an altitude? Well, here's why we care. If I have this big right triangle ABC here with its right angle tucked in the corner, what if from the right angle I drew an altitude out to the hypotenuse? What I'll have done is created like a mini right triangle, and in fact, two mini right triangles inside a larger right triangle. Okay, fine. Well, what's an altitude? An altitude is technically a height, it's a segment from a vertex perpendicular to the opposite side. Okay. And in this picture, the segment or segments in the diagram that are altitudes, the obvious one is here is CD because that's the height of the triangle. But technically, AC and CB are also altitudes because in a right triangle, if I were to turn this triangle like this way, and I had A and B and C right here, BC could be an altitude because that would be the height of the triangle. And if I turned it again, and I had, pardon me, this would be A and C and B, AC could also be a height. Okay, but really, rewind. Blah, 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 blah. The most important altitude that we're going to talk about today is CD when I draw the altitude from the right angle. Okay, fine. Well, what do I do next? It says if A is 35, find all the other missing angles. All right, fine. So if A is 35 and that thing's 90, the three angles in a triangle have to add up to 180. So if I said 180 minus 90 is 90, 90 minus 35 is going to be 55. All right, fine. Well, up here at the top, all of angle C needs to be 90. 55 plus 35 is 90. And then again, I have another 55 here. And so what I'm realizing is the triangle on the left and the triangle on the right have the exact same angles. And in fact, this triangle right here has the same angles as this triangle right here. And my big triangle overall still has a 35 and a 55 in it. So what does this imply? All the triangles are similar to one another. And that's important because similar triangles have proportional sides. And that's what this whole lesson is going to be about. That similar triangles have proportional sides. You just have to match those proportions up. So let me just put this back real quick so I can reference it in a minute. So if we had to make some similarity statements, triangle ADC, that's the one on the left, is similar to the one on the right. Well, if I said ADC, then that would be similar to CDB because angle A, which is 35, matches with little angle C, which is also 35. The D's are both 90. And then angle C and angle B are both 55. So ADC is similar to CDB. That's left is similar to right. CDB, which is the one on the right, can be similar to the whole triangle if I pay attention carefully. So CDB goes 35, 90, 55. If I do that for the entire triangle, that's going to be triangle ACB. And then ADC, which is the one on the left, can be similar to the whole thing. ADC, 35, 90, 55. For the whole thing, that would be ACB. Okay. Again, though, what am I really doing? I am showing that this triangle right here is similar to this triangle right here, and they are both similar to the whole triangle overall. Okay. Now, let's leave that behind and get some numbers so we can find some concrete evidence of similarity. So if I come down here and have that exact same picture, but with measurements in it, what we can do is compare all the corresponding sides to find the missing measurements. All right. So in this triangle, there are three triangles. There's the one on the left, the one on the right, and the whole. Each of those kind of has some different sizes. So what I've described them as is small triangle, medium triangle, and big triangle. Each triangle has three sides. It has a short leg, it has a long leg, and it has a hypotenuse. And just a reminder, the legs are the ones that create the 90-degree angle. Okay. So let's take a second and look at the small triangle. Let's look at this triangle right here. Okay. The short leg, meaning the short segment that creates a 90-degree angle, has a length of 3. That's right here. The long leg, the other piece that creates the 90-degree angle, is y, and the hypotenuse is always the thing across from the 90-degree angle, and that's z. Okay, so in the small triangle, there is a short leg, a long leg, and a hypotenuse, 3yz. Now, I'm going to walk away from that triangle and go to the medium triangle. That's this one right here. In that medium triangle, the short leg would be y because the 90-degree angle is right there. Y looks smaller than 12. So y is the short leg here. The long leg is 12. And the hypotenuse is the thing across from the 90-degree angle. That's going to be x. All right. Now let's walk away from that triangle and look at the big triangle, also known as the whole thing. In this big triangle, here's my 90-degree angle. The short side of that 90-degree angle is z. The long side is x. And the hypotenuse is this whole thing down here, 12 plus 3, which is 15. Now, what I can do with this table is I can say, I'm going to compare the corresponding sides and make proportions. When we did similar figures, we created proportions. Well, I have proportions right in here. I can make a proportion out of anything that makes a box of 4 numbers. Okay, so the first proportion that I see is this box of numbers right here, 3y, y12. That means that if I want to solve for y, I can come up here and say 3 over y equals y over 12. Okay, what I'm doing is I'm saying the short leg of the small and the medium triangle have a ratio of 3 to y, and the long legs have a ratio of y to 12. Make a proportion, solve for y. Okay, fine. I'm going to cross multiply. 3 times 12 equals y times y. 3 times 12 is 36. Y times y is y squared. If I want to solve for y, I'm going to square root both. And now I get y equals 6. I know that's 6 units long. And if I want, I can even come in here in this table and change those y's into 6's. Cool. All right, well, I still need to find x and z. And if I look over here at x, I'm realizing that I have another box down here of 12x, x, and 15. Oh, that works out kind of nicely. So let's make a proportion out of that. 12 over x equals x over 15. X squared equals 12 times 15. Okay, so that's going to be x squared equals, let's pull a calculator out here. I'm going to grab mine. So 12 times 15 is 180. And then I'm going to square root both sides. So x is the square root of 180. It says let's leave our answers in simplest radical form. 180 isn't a perfect square. So if I want to reduce this to simplest radical form, I need to find the biggest perfect square that goes into 180. And if I do 180, I'm going to find out that 180 is 36 times 5. which means x is 6 root 5. All right. So y was 6, and x over here is 6 root 5. Fine. And then last but not least, I need to find z. So if I come here and I try to find z, let's see, here's a z, okay? And here's another z. Fun fact, you can either make a box of 4 numbers or you can use the 4 corners. Now, this isn't highlighting appropriately, so I'm going to circle it. I can circle the 4 corners and use those to make a proportion. 3 over z equals z over 15. Okay. And now I have a proportion that looks a lot like the other ones. Cross multiply, z squared equals 45. Square root both. 45 is 9 times 5, which makes this 3 root 5. Okay. Now, we don't normally have that many unknowns, but this was a great way to say you can technically find everything in the figure just by setting up a chart and then making proportions from it. So now, with less talking and more doing, let's do this again here. It says complete the table and then use it to solve for the missing variables. Now, one thing I forgot to put on this first diagram here is I forgot to tell you that this is a right angle and so are these. Okay, so put that in there. And if I have an altitude drawn inside of a right triangle, I will always get similar figures. I will have a small triangle, a medium triangle, and a large triangle, and each of those have 3 separate sides. So what we're going to do is to find the missing pieces is we're just going to fill out everything we have and solve for what we need, okay? So in the small triangle, that's this one right here, the short leg is 2. The long leg is the other thing that makes the right angle, that's y. And the hypotenuse is 6. In the medium triangle, I'll do that in red. In this medium triangle, which is this thing right here, the short leg that makes up the right angle is the y. The long leg that makes up the right angle is an x. And the hypotenuse, which is right here, doesn't have a marking on it. So I'm not going to put anything in the box. Okay? And then inside the large triangle, which is the whole thing, the short leg is 6. The long leg is not marked. And the hypotenuse, which is this whole thing right here, would be x plus 2. Okay, so now I need to solve. Well, one option is I look at this and I see a box right here, 2 over y equals y over x. Yeah, that's too many unknowns. I would be missing x and y, so I'm not going to use that. Now I'm going to look at the 4 corners. 2 over 6 equals 6 over x plus 2. That I can use. It only has one variable. 2 over 6 equals 6 over x plus 2. 6 times 6 equals 2 times x plus 2. That's going to be 36. Distribute that 2 equals 2x plus 4. Now I need to solve for x, so I'm going to subtract 4. Let's see, 36 minus 4 is 32 equals 2x. Divide by 2, and I get x equals 16. So now I can come back in the table and say x is 16. And now I can use that yellow box and say 2 over y equals y over 16, and then cross multiply to solve. Y squared equals 32. 32 is 16 times 2, which makes 4 root 2. Now, it says here, unless told otherwise, round to the nearest tenth. This is simplest radical form, but one it said was round to the nearest tenth. So what I really want to do with this is I want to use a calculator and type 4 root 2 into that calculator to get a number to the nearest tenth. All right. So 4 root 2 is 5.65, which would be 5.7 when rounded to the nearest tenth. Okay. All right, let's try another one. Ooh, there's even less given here, so my table's going to be a little bit smaller. So in my small triangle, that's this one right here, the short leg is 4, the long leg is x, and the hypotenuse isn't marked. Fine. In the medium triangle, the short leg is x, the long leg is 9, and the hypotenuse isn't marked. And then in the large overall triangle, the short leg, which is AD, isn't marked. The long leg, which is DB, isn't marked. And the hypotenuse is 9 plus 4, which is 13. I have a box. I can solve for x. 4 over x equals x over 9. Cross multiply, x squared equals 36, which means x equals 6. And that's all we needed there. Okay. And last but not least, number 3. Here's my baby triangle. In my small triangle, the short leg is 4, the long leg is y, and my hypotenuse is not marked. In the medium triangle, the short leg is y, the long leg is 16. And you know what? I'm just going to stop writing because I realize right now I have everything I need. 4 over y equals y over 16. Cross multiply, y squared is 64. And the square root of 64 is 8. And that's it. That's all I need. Okay. So when doing problems with an altitude drawn to the hypotenuse of a right triangle, you want to create this chart. Now, I have the chart given for you. If you look at the homework, I gave you some of the charts, but then I make you make your own chart later on because I got to be honest, that chart's not going to be given to you. It's a strategy to help you solve these problems. Okay, so the big picture here is that when you have a right triangle, meaning like this whole thing, and you draw an altitude inside of that right triangle, you get 3 similar triangles. And if you want to find the missing lengths, you need to create proportions. And the easiest way to create those proportions is to just line up all the corresponding parts and use that table to set your proportions up and cross multiply. So I am signing off. I hope this makes some sense and everybody's having a great day. See ya.